Hey, we are looking at graphing ordered pairs and we're looking at an example problem. If you already understood things from the last two videos, you might just want to jump into the must-do problems in Canvas. However, if you need a little bit more time and you want to see another problem, let's do one more up on the board. So our equation that we're going to use this time is y is equal to negative x plus 5. Y is equal to negative x plus 5 is what we're going to be looking at. Ooh, my hair is special today. You guys are just going to have to deal with it. All right, so y equals negative x plus 5. We are going to have the same sort of t-chart scenario, that double t-chart where we have x's, y is equal to negative x plus 5, and y in there. Cool? And when we do this, we are going to find a bunch of ordered pairs that we can then graph on a coordinate plane. It's going to be so awesome. So looking at this equation, a couple of things strike me right away. Well, at least one thing strikes me right away. I see a negative x. And if we remember from our classes from the last module, when we see something with a negative and a variable, and there's no number in between that's specified, there is one invisible number that can always be invisible. But this is, remember, it's like the kid that hides behind the curtain, that like the little 4-year-old that hides behind the curtain that's horrible at playing hide and seek. This is that invisible number sort of scenario. This negative is like the feet sticking out underneath that curtain. Do you remember that analogy that we had in class? Hopefully that's ringing a bell. And if that's the case, the only number that can be invisible but like kind of still peeking out is a negative 1. So I highly suggest that if you have a situation like this where you have a negative variable, please always add in that invisible number 1 so you can make sure that you are going to deal with this in the correct way. So just like before, I'm going to put my same 5 numbers, same 5 numbers on there that I used last time. Negative 2, negative 1, 0, 1, 2. I can see negatives, I can see 0, and I can see positives. And I can see how this graph of this line reacts to those various numbers. So starting out, we are going to put this input of negative 2 into this equation and for x and figure out what happens with it. Now notice I have, again, this negative x, which we know is negative 1x, and I have negative values for x. So look at how I'm dealing with this scenario. I have y is equal to negative 1 times negative 2 plus 5. So even though my equation has a negative in it, my x value is negative, and those will then have to like rectify themselves. We have 2 negatives multiplying each other. That's something that often like sort of kicks people's anxiety up a little bit when we're looking at these equations. So make sure you are paying attention to the fact that there is a negative 1 up in front, and my x value that I'm putting into this is negative. So negative 1 times negative 2 gets me a positive 2. Plus 5 gets me 7. So I have the coordinate pair negative 2, comma 7. And notice the negative 2 goes up in front because our coordinate pairs are x values, then comma y values every single time. I'm going to do the same thing with this negative 1. Ooh, watch this. I already have a negative 1 in my equation. Now my x is also equal to negative 1. So I have negative 1 times a negative 1. So awkward. Plus 5. Negative 1 times negative 1 gets me a positive 1. Plus 5 gets me 6. So I have negative 1 comma 6 for my next point. I'm now going to put 0 into that equation. Y is equal to negative 1 times 0 plus 5. Negative 1 times 0 is 0 plus 5 is 5. 0 comma 5. I'm going to put 1 in there now. Negative 1 times a positive 1 plus 5. Negative times a positive is a negative. Negative 1 times 1 is negative 1 plus 5 is 4. I really hope, just like in the last video, you're starting to see a pattern in these numbers in the y, in the outputs. So 7, 6, 5, 4, 3 is going to be my predicted value there. Let's see if we're accurate in that. y is equal to -1 times 2 plus 5. -1 times 2 will get me a -2. -2 plus 5 gives me a +3. My prediction was accurate. So I have 2, 3 for my next point. Now I'm going to take those coordinate points and I'm going to graph them. Here we go. Here's my trusty handy dandy graph paper. So I'm going to take all of these coordinate points that hopefully you can still see, -2, 7, -1, 6, 0, 5, 1, 4, and 2, 3. And I'm going to graph them on here. I need to remember that this is my x-axis, and I'm going to start with graphing my first coordinate pair, or first ordered pair number on the x-axis. So it's -2. Here is 0, 0. So -2 from there, -1, -2. And then from there, I have to go up 7. Let's hope I can reach. I'm really short, right? 1, 2, 3, 4, 5, 6, 7. Barely can reach. -2, 7 is that coordinate point right up there. I have -1, 6 next. -1, 1, 2, 3, 4, 5, 6. Notice I'm trying to keep myself really accurate. I'm literally putting little slashes on each value as I'm going up and plotting these points. And I do that so that way I can keep myself really accurate with this. I'm now going to go 0, 5. So I'm not going to move it all on my x-axis, and I'm just going to go up 5 on my y-axis. 0, 5. Next one, 1, 4. So from here, I'm going to go over 1 and up 1, 2, 3, 4. 1, 4. And last but not least, I have 2, 3. 1, 2. 1, 2, 3. 2, 3. All right. So now I have 5 points that I have graphed on here. Now I am going to connect the dots. And when I connect the dots, I am going to make sure my arrow fills, or my line fills up as much of the graph as I possibly can. I'm going to make sure I have arrows on both ends. Now, I don't want you to spend tons of time making sure this is going all the way across the graph super accurately. You can see that I probably got off a little ways. I do want you to be fairly careful in that you're not going to create a huge curve, but just draw a straight line as much as you can. If you need to, and if you're like sort of have like a worry about it, grab a ruler and draw a line with a ruler so you can make sure it's super straight. I tend to just eyeball it. It's okay. The biggest thing is that I am not going to draw a line that looks like this, right? It's not going to totally go off the deep end. I'm going to make sure I'm at least trying to show a straight line as much as I can. Notice I still have my arrows on both ends. You can see them nice and big. My line goes as far through the graph as I possibly can reach, and I have 5 points plotted. All right, so there was our example problem. You've now seen this happen twice. I want you to please try the must-do problems, and don't forget to take the exit pass for this lesson. I'll see you later. Bye.